Okay, it started. And I will share the notes with you. There you go. Okay. As I told you, we will start with solution of linear first order differential equations and the solution technique, what we call it integrating factor. I will tell you how we will do it step by step. But firstly, the linear first order differential equation, ordinary differential equation, has this form. And this f of ty is linear, which means that, you know, y is alone and the constants will be, the coefficients will be either constant or depending on the independent variable, right? We talked about the classification last time, and we know what is the form of the linear differential equation. And this is the form of the linear differential equation. And here a and b is constant. So last time, last class, we modeled owl and mice population, and also we modeled the free fall. And all of these were the examples of the constant coefficient linear differential equation like that. But these coefficients can be variable like that. So we can have a variable linear differential equation, which means that the coefficient of y can be p of t. And even we can have a coefficient of the y derivative that depends on t. So once we have this kind of equations, how we can solve it? Today we will discuss that. And this is just for the reminder for the constant coefficient case. And what we were doing, we were firstly factoring out the a, and after that we were collecting the y terms in one side and t terms in other side. We were taking the integral and finding the solution for y. And we did two examples in last class. Make sure that check it out. Actually, today we will be also talking about separable equations, and this is an example of a separable equation. And for the variable coefficient case, this is the general form of the linear first order ordinary differential equation. And in here, to be able to solve that, our approach is the method of integrating factors. So we will try to find one factor. Once we multiply this factor with our equation, we can solve it easily. Okay, this is the A. And this factor, we call it integrating factor, because once we multiply the equation with that integrating factor, by just taking the integral of each side, we can solve this equation easily. That's the aim, okay? And integrating factor is showing with the mu of t function. So how do we solve it? Step by step, I will explain to you. Here you go. The equation can be given to you in that form. As you can see here, there is a derivative term and the coefficient of derivative term that depends on t. And there is a y term and the coefficient depends on t. And the right hand side, g of t. And if it is given in that form, this is the general form. As a first step, you need to put this one into a standard form. What does standard form means? The derivative of the coefficient of the derivative term should be 1, which means that you need to divide this equation by a1t, the coefficient of the derivative term. Once you have it, this is what you, this t is a0 over a1, g of t is this g of t is g of t over a1. Okay, so you need to turn this equation into that form, that the derivative is staying alone, the coefficient is only 1. So as a first step, this is what you need to do. Put your differential equation in the standard form like that. After that, you need to compute an integrating factor. What is integrating factor in that standard form? It is e to the integral p of t dt. P of t is the coefficient of y term. Okay? You need to compute You need to find this mu of t. Once you find this mu of t, you need to multiply this mu of t with your standard form. And this is what you will get. Multiply the standard form by the integrating factor. Once you do this, this is always the case, your left-hand side will be the derivative of mu of ty. That's why we are multiplying our equation with that integrating factor. Because our left-hand side will be always the derivative of mu of ty. And the right-hand side is mu of tgt. And after that, what you need to do is, since you are trying to find what is y, you are trying to solve your differential equation, and your y is your dependent variable, what you need to do is take the integral of each side. Integral of derivative is gonna cancel each other. You will have only mu of t y on the left hand side, and on the right hand side it will be the integral of mu of t gt. There will be c is coming, and you need to solve this one for y by dividing the equation for mu of t. So this is the general solution of first order variable coefficient linear differential equation. Okay? I don't want you to use that one. I want you to show your solution step by step like that. Okay? Do you have any question? Let's do it on a normal example. After that, I will take your questions. For example, this is your differential equation. 2y derivative plus y equals e to the t over 3. As you can see, this is like a1y prime plus a2y equals g of t, right? So as a first step, we need to put this one into a standard form. What did we say? The y derivative term should be alone, which means that I need to divide my equation by 2. If I divide this by 2, this will be y derivative. This is 1 over 2y. This is e to the t over 3 over 2, right? This is the step 1. After that, find the integrating factor. What was the integrating factor? E to the integral p of t dt. P of t is the coefficient of y term. And that's why I am taking e to the integral 1 over 2 dt. The integral of 1 over 2 is just t. T over 2 is going to be my integral. Don't put c because we will put c at the end. So all the constants you can think like combining at the end. Okay? And this is your integrating factor. And as a next step, you'll need to multiply this integrating factor with your standard form. Multiply that one, e to the t over t y prime plus 1 over 2 e to the t over 2y equals 1 over 2 e to the t over 3 times e to the t over 2. And what did we say? Once we do that, once we multiply our equation with mu of t, our left-hand side will be always mu of t times y's derivative. This was my mu of t. This is y. Its derivative equals to the g of t, which is 1 over 2 e to the t over t times mu of t. Here you go. And now the calculation is easy. Take the integral of each side, solve for y. Let's take the integral of each side. Integral derivative is gonna cancel each other. We have only e to the t over ty. In this one, you know that e to the 3 over 2, e to the t over 2, e to the t over 3. Once you multiply it, you can add the powers. And the integral of that one is the coefficient of the t, which is 1 over 2 e to the 5t over 6 over 5 over 6. And this is what you will get, plus c. And if you solve this one for y by dividing it e to the t over 2, and this is what you will get for the general solution. So, do you have any question? I'm waiting. As a first step, put it in the standard form. As a second step, calculate the integrating factor. As a third step, multiply your equation by an integrating factor. And the left-hand side will be always d dt mu of t y. And then take the integral, solve for y. That's it. These are the steps to solve differential equation linear differential equations. Okay, and this is another example. This is our differential equation. As you can see, this is already in standard form because the coefficient of the derivative term is 1. So already in standard form, this is what I have. Y prime minus 2y equals 4 minus t. And now as a second step, integrating factor, integral p of t dt minus 2 dt. You know the integral of minus 2 is minus 2t. And I will multiply this mu of t by the first equation, term by term, e to the minus 2t y prime minus 2 e to the minus 2t y equals this term times e to the minus 2t. And the left-hand side will be always like the derivative of mu of t y. You can check that your calculation actually up here if it is true or not. Check that. According to the product rule, the derivative of the first one times second plus first one times the derivative of the second. Exactly, you will get the left-hand side in step 3. And after that, what you need to do? Take the integral of each side, solve for y. Take the integral of each side. This integral derivative is simplifying each other. We have e to the minus 2ty, and there we can distribute the exponential function over the polynomial. You have this integral and that integral. Solving this integral is easy. For that one, you need to do integration by parts. If you call what is that, ut dv e to the minus 2t, uv minus integral v du, you know that. Remember integration by parts. And you can find the integral on the right hand side in this way. And if you solve for y by dividing the equation for e to the minus 2t, this is what you will get as a solution. Again, you know, this is the worst thing for the online things. I cannot write it, but try to, you know, follow it once I am explaining. And if you don't understand anything, you can stop me and ask. But doing the integral part, you're supposed to know it so far. So make sure that you know how to do integration by parts, how to take the integrals of different functions. Turn back to your calculus and check your notes. And these are the solution for the this differential equation. I already provide you the MATLAB files. You can just plug in there and you can see the direction field and the solutions easily. And this is just one example that we took from there. Any questions so far? I assume no, because I don't get any answer. No? How many? We have 28. Okay, another example. To solve the initial value problem. This time we will solve the initial value problem. That's the difference. Once we find the general solution, we will plug in 1 for t, make it equal to 2, and we will find the constant c. Okay? So as a first step, put this into a standard form. Divide the equation by t. So we have y prime 2 over ty, 4t square over t, which is 40. That's good. And then we need to find the integrating factor, which is the e to the integral p of t dt. Integral 2 over t dt, it is 2 ln t. You know that the integral of 1 over t is ln t. And this is the same as, you can move this 2 as a power inside the ln. So I will assume this is ln t squared. Since exponential and the ln is simplifying each other, we have t squared as an integrating factor. So I will multiply my standard form with the t squared. So this t squared y prime, t squared times that, t squared times the right hand side. And we know that the left hand side will be always the derivative of mu of t, which is t squared times y. And the right hand side 4t cubes integral. Then if once you take the integral, we have t squared y for left And for right, t to the 4 over 4, so we have only t to the 4 plus c. And if I solve for y, this will be t to the 4 over t square, which is t squared, plus c over t squared. This is the general solution of my differential equation. And to be able to find the initial value problem, I will plug in 1 for t, make this one equal to 2, and find c. And exactly, I plugged 1 for t, this is 1, this is c, y will be 2, so c will be 1 plus c equals 2, c will be 1. If c is 1, in the general solution, I plugged in 1 for c, and this is the solution of the initial value problem. And you can see the solution curves for different initial values in here. And you can do it with MATLAB. You can use hold on and you can plot different solutions like that. Okay. So, do you understand the linear equation? Do you follow me? I want to get some So,
Yes.
okay, great. So if there's a particular place that was not make sense, please let me know. You know, I solved like 4 or 5 examples here. And also I provide you in LMS, if you look at the LMS, I provide you the lecture notes from my written lecture notes. If you open there, you can see different examples here, by the way. So if these examples were not enough for you, you can see different examples there. And this, you know, you can solve by yourself them. Okay, this is, for example, another example. You are putting it into a standard form. And once you put into the standard form, you are finding the integrating factor, integral of t plus 1 over t. You can think as 1 plus 1 over t. The integral of 1 is t. The integral of, do you see me?
I don't see your screen.
Oh, sorry. Yeah, I think I'm not sharing that. I thought I'm sharing this one. Let me share. Sorry, it's gonna be better. Stop sharing this. Let me share my desktop so that you can follow me easily. I opened this one from our LMS page. I already shared you the last year's written notes that I wrote, and in there you can see different examples. And I was talking about this example. Solve the initial value problem. This is our differential equation. As you can see, this is a linear differential equation, variable coefficients, and we know how we are solving it. Firstly, we need to put this one into a standard form by dividing it with a1, which is the coefficient of y derivative, which is t. If I divide it by, this is what we get. And in here, we need to find the integrating factor as a step 2, and our p of t function is here, the coefficient of y. And e to the integral p of t dt, since this is the same as t over t, which is 1 plus 1 over t, and the integral of 1 is t, integral of 1 over t is ln t. So, since this is as a summation as power, you can write as a multiplication with two exponential functions, e to the t, e to the ln t. E and ln t is kind of simplifying each other. You have t times e to the t as an integrating factor. And in the next step, we are multiplying our standard form with that integrating factor. As you can see, this is my integrating factor. This is my equation from the first step. And our left-hand side, once you do that, is always d dt mu of t times y. Mu of t is t e to the t times y. And right-hand side, this times the 2e to the minus t, we have only 2t. Take the integral. Here, derivative integral is simplifying. We have only the parentheses function. And in there, this is t squared over 2, so t squared plus c. Solve this one for y by dividing its own coefficient. And here you go. This is your general solution. And what is the initial value problem? Y1 is given 0, which means that when t is 1, y should be 0. So plugged in 140, make it equal to 0, solve for c. Since y1 is 0, we want to choose c, so when t is 1, plugged in t1 and make it equal to 0, you have e to the minus 1 plus c times e to the minus 1, 0. And there you can see that c is -1. If c is -1, just plug it in and this will be the solution of your initial value problem. And also in Pearson, you can find different examples there. Make sure that you registered, you have an access to MyLab. And in MyLab, you can find different examples about the solutions of these linear differential equations. Okay? So, if you don't have a question, I will go through with the separable equations.
Hocam sesim geliyor mu?
Evet.
Pearson için sizin şifrenizi mi alacağız yoksa kitabı alınca bize şifre mi verecekler?
Kitabı alınca size şifre verecekler.
Tamam.
O şifreyle girerken hangi derse kayıt olmak istiyorsunuz diye bir option var. O option'da benim dersimin kodunu yazacaksınız. Ve o derse kayıt olacaksınız.
Option'ı duydum. Bir öncesinde sesiniz kesildi.
Öncelikle satın aldığınızda sizin mail adresinize bir şifre gelecek. O şifreyle Pearson'ın MyLab'e kayıt olacaksınız. Kayıt olduktan sonra size hangi derse kayıt olmak istediğinizi soracak. Bu durumda benim ders kodumu girmeniz lazım. Şurada ben size
hocam,
geçen lecture 1 notes var ya, geçen hafta paylaştığım. Şurada söylüyor aslında tam olarak ne olacağı. Bu slayta bakarsanız şurada da bizim ders course ID'miz var. Bu course ID ile arayıp bulabilirsiniz.
Tamamdır. Teşekkür ederim.
So I was telling about how you can get the Pearson. If you will have a question, you can ask me again. Now let's continue with the separable equations. Actually, this is easier. You are already familiar with the separable equations. So we examine a subclass of linear or nonlinear. It doesn't matter, first order equations again. But the property for the separable equations is you can collect the terms near each other in different sides of the equation. So if you can write your equation in that way, which means that you have a separable equation. Okay, so for example, this is the equation, and as you can see, this is a nonlinear equation because 1 minus y squared dy. We said that the derivative of y cannot have y terms. It can only have x terms. That's why this is a nonlinear differential equation. But what you can do, you can separate the y terms and x terms in different sides of the equation. For example, this is the same as dy 1 minus y squared and dx x squared. So as a first step, you need to separate the variables. And if you have only y terms in one side and if you have only x terms in other side, what you can do is just integrate both sides and solve for y. That's it. It's so easy. So the integral of 1 is y. The integral of y squared is y cubed over 3. The integral of x squared is x cubed over 3 plus 1c. You can adjust the c on the right hand side like that. And if you can solve for y, solve for y. If you cannot solve it, which means that your solution is an implicit solution. This is an implicit solution because y cubed term there is a y term, so you cannot solve for y. That's why this is an implicit solution. Okay. And this is another example. Here it is. As you can see, again, you can multiply, cross multiplication. This term times dy equals this term times dx. And in here, there is only y term. In here, there is only x term, which means that this is a separable equation. And once you separate these terms, what you need to do is just take the integral of each side and solve for y. Once you do that, y square minus y, 2y, because there's 2 here, and this is y square over 2, 2's are gone, that's why we have only y square, x cube over 3, so we have x cube, x square over 2, that's why we have 2x square, and 2x plus c. As you can see, this also looks like a implicit function, because there is not like y equals some x function. But this implicit function, you can write it explicitly also like that, which means that you can solve your y equations like the second order quadratic formula you can use. And once you use the quadratic formula, you can write your solution for y. And this is the explicit version of your solution. This is the implicit version of your solution. Okay? Sorry for that. Okay. And since this is an initial, okay, we can make this one as an initial value problem if we specify an initial value, which means that when x is 0, y is negative 1. So plugged in x0 and y1, you will find C3 if you plugged in the implicit function. But if you plugged in the explicit function, you will find C4. But these are all same thing. What is the difference? You are just plugging it in the different function. Okay, C is just a constant. Since you are rewriting your function, you can find different C's, but it doesn't matter. Your solution is telling you the same story. Similarly, here, consider the following initial value problem. If you have this kind of equation, you can write your left-hand side as dy dx. If this is dy dx, again with cross multiplication, I can easily separate my variables. dy times 4 plus y cube, dx times 4x cube. Take the integral, solve for y if you can. If you cannot solve for y, just put your equation into an implicit form, plugged in 0 for x, 1 for y, and solve the c. Okay? And another one. Do you have a question for the separable ones? This is easier. What you need to do is just write the variables in 2 different sides. That one. Think about that. How you can separate x and y terms. Please take pen and paper and try. My son just woke up. Yes. Y plus 1 goes to the other side. Exactly. So what you have, let me see, x squared goes to the other side, which means that you have only y plus 1 dy, and this is staying here, but x squared is coming as a denominator here, and this is what you will have once you separate the variables, right? Yeah, after that, same thing, exactly. What is same thing? Take the integral, solve for y. That's it. Take the integral of y is y squared, sorry, y plus 1, you can think as like that. And also what you have for the right hand side, you can easily think that you can easily solve this one as a partial fraction decomposition. Remember that, or check, Google it, partial fraction decomposition. You already know how to take the integral for this kind of polynomial functions as it is given as a rational function. Since this is x squared, you can think this one as ax plus b over x squared, or you can take it twice like this, a over x plus b over x squared, and for that one, c over x plus 1, and you need to make this one equal to the same equation inside here, and once you do this, you need to find the a, b, c, so that you can write this equation separately and you can take these integrals easily, right? Because you cannot take this integral. And if you do this, you will have a1, b minus 2, c3, and you have 1 over x, the integral is ln x. You have minus 2 over x squared. You know the integral is, you can think this one is x to the minus 2. So the power is coming as a denominator, and you are adding 1 to the power. And this is what you will get as 2 over x. And for the last one, again, ln x plus 1 will be the integral of your result. And since the initial value is given as when x is 1, y 1, exactly we are applying that here. X is 1, y is 1, so y is 1, x is 1, and solve it for d. D is minus 3 ln 2. If you can plug in, you can find your solution of your initial value problem. Again, please do it by yourself with pen and paper without looking the solutions here. You need to remember the integral part. Once you remember the integral part, the solutions are not hard, but you need to remember the integral part. Now I want you to solve this one. Pen and paper time. This is the last example, last thing that I will ask from you. I'm waiting you. I'm waiting an answer from you. I will, I'll. You can still hear me, right? It's gone for a while. Great. So, great. So answer. Write it. Separate it. Again, exactly. y dy equals x to the 6 dx, right? Write it in a paper. Take the integral. Take the integral of each side. Make sure that everyone is because this is the easiest one you can find. At least make sure that you understand this one and you are able to find the answer easily. It can take just 2 minutes for you to solve it. Again, as a hint, for the left-hand side, if it is given like that, you can write your dependent variable in terms of independent one as dy dx. And for the cross multiplication, y dy equals x to the 6 dx. Take the integral of each side, y square over 2, x to the 7 over 7 plus c, right? That's it. And you can solve for y, or you can put this one as implicitly as you wish. I think put the answer here. Y dy x to the 6 dx. Take the integral of each side, y square over 2, x to the 7 over 7. Or you can just, make the denominators equals to each other and you can write your implicit solution like that. Or you can solve this one for y by taking the square root. Okay? Doesn't matter which one you prefer. So do you understand that? Because this was the last, yeah. Again, you can find answers. I already assign you, show you. Great. Lecture 3 notes and lecture 4 notes. You can also find separable equations here from last year, different examples. After that, next time we will be talking about modeling with first order equations and then autonomous equations, and we will go through from there. Okay. I will be sharing with you the written notes like that, so that you can have different examples in your hand. And also, once you have the Pearson, you will have infinite number of examples with you, so that you can solve and you can do practice easily. Any question? Okay. Okay, so we did linear differential equation and separable one. Separable one was easy. Just collect the terms in different sides of the equation and take the integral, solve for y. For the linear one, we had different steps. I specifically divided into the steps so that you can, easily remember that. For the first step, you are putting into the standard form. As in the second step, you can find the integrating factor, then multiply your integrating factor with your equation. Once you do that, your left-hand side will be always the derivative of mu of t, y. Mu of t is your integrating factor. Take the integral, solve for y. That's it. If you can do it, please do it with pen and paper by yourself, couple examples. You will see that it is easy and you can do it, easily in couple minutes. Just remember how you were solving integrals. Okay? Then that's it for today. We will continue next Tuesday. I will assign your first homework this weekend. Okay. See you. Now I'm starting recording.
Bir şey